This is your multiplying monomials worksheet, and we're going to do the odds together. But before we do, I want to give you a quick recap of the exponent rule we've learned so far. Okay, so we have learned when your base, this is called a base, and the number that's floating up to the right, top right, is called the exponent. When your base is actually something you don't know, like a variable, you can still combine these things together by just adding the exponents. X to the power of 2 times x to the power of 3 gives me x to the power of 5. I just added the 2 and the 3. The common mistake with these is people see multiply and they do 2 times 3. And that's not right. It's not 6, it's 5. Okay? The thing that might help you is just remember, when you're multiplying these, you add the little numbers, the exponents, you multiply the big numbers, like the base. If I had like a coefficient, if I had a coefficient in the front, I would multiply that, and we'll see that on this paper. Let me give you a quick rundown of what, just to prove that this works. Here I just replaced my x with the number 2. So I'll put 2 to the power of 2 times 2 to the power of 3. That gives me 2 to the power of 5. Okay, now what is 2 to the power of 5? That would be, and there's two ways you can put it in the calculator. That would be 2 times 2 times 2 times 2 times 2. That's 2 times itself 5 times. That gives me 32. I could also, just as an extra here, I'm going to show you how to just put 2 to the power of 5 in the calculator. 2, and you use this caret top button right here to get a little exponent template box. Type in your 5, and you get 32 that way as well. Okay? So this is the same thing as this, and they both give you the same answer, 32. Now, we're not going to be getting answers on these because we're dealing with variables. So our answers are going to have some numbers, some variables. All right. First one is simple. A to the second times a to the third times a to the sixth. We're adding the exponent numbers. 2 plus 3 is 5. 5 plus 6 is 11. So we get a to the 11. I just added those exponents. Number 3 here. Notice the big numbers. And my rule of thumb is you multiply the big numbers, you add the little numbers. So 3 times 4 is 12. All right. And then 4 plus 2 is 6. They have to have the same base though. This is p to the 4, p to the 2. That tells me I can add the 4 and the 2. So I get 12p to the 6. Let's try number 5. Number 5, we have some big numbers here that we're going to multiply. Negative 4 times times positive 3 is negative 12. Now we look at the exponents. This and this have the same base. The base is x. So I can add the 4 and the 2. 4 and 2 gives me 6. So I get x to the 6. So my answer here is negative 12 x to the 6. Number 7, we're going to multiply these. But when I say multiply, I'm actually adding the exponents. I add this and this. Now, there's no number here. So you want to write in a little 1 here. That is b to the power of 1. It's an invisible 1. That's important to do because you're adding the 4 and the 1. You get b to the 5th. Okay? And then here, y to the 3rd and y to the 5th. I can add those and get y to the 8th. Notice how I approached this. I totally ignored the y's at first, and I just added my b exponents. And then I added my y exponents. Okay? Number 9, we want to do the big numbers first, and that is multiply. 3 times negative 4 is negative 12. Then I do my exponents. I have a base of s first. Here's an exponent of 3. On this base of s, I don't have an exponent. I want to put in a little 1 there so I don't forget. There actually is an invisible 1. The 3 plus the 1 makes it s to the power of 4. And now for my v. v to the 5th, and then v to the 3rd, The 5 plus 3 gives me v to the 8th. So I have negative 12, s to the 4th, v to the 8th. Number 11, we're going to go ahead and multiply the big numbers. Negative 4 times negative 6 gives me positive 24. Okay? Now I'm looking at my x to the 6th, but I don't have any more x's in here, so nothing changes with that part. I'm just going to write x to the 6th. On this last one, I have y to the 3rd and y to the 1. I remember to write in the 1. 3 plus 1 is 4. That gives me y to the 4th. So this is 24x to the 6th, y to the 4th. Now we have a few short word problems that we'll do together, the odd ones. Number 13, which best represents the area of a rectangle? Well, first of all, before we keep reading, let's remind ourselves of a rectangle. And area means the inside space of the rectangle. That's going to be length times width. Area of a rectangle is equal to the length times the width. You have to know that kind of going into this. And now they're going to give us the length. With a length of 8m to the 3rd and a width of 4x squared m to the 4th. Now that sounds weird, but it's really the same thing we've been doing. I'm going to make another rectangle. We have a length of 8m to the 3rd and a width of 4x squared m to the 4th. Since we know that area is just multiplying the length times the width, we're going to multiply these two numbers. So I'm going to write them side by side. 8m to the 3rd times, and you can do it with parentheses, you can do it with a dot, it all means the same thing, however you want to write it, 4x squared m to the 4th. Now when I multiply it, take a look at this. Once I came up with it, it looks really similar to number 11 or number 9. It's basically the same as these types of problems. I'm going to multiply my big numbers first. 8 times 4 is 32. Now look at your answer choices. We've already got it narrowed down to either A or C. Because B, they mistakenly did 8 plus 4 and got 12. And here, they must have did 8 divided by 4 and got 2. That's weird. So those are both wrong. Okay, we had to multiply those big numbers. The x has no other x's with it. I'm not adding any exponents to that. So I'm going to go ahead and write x squared. But I'm going to put that on the end. Okay, the m, I have m to the 3rd and m to the 4th. I add those together and get m to the 7th. This one's correct. This one, they multiplied the exponents and they got 12. They did 3 times 4. That's not correct. You add the exponents, you multiply the big coefficient numbers. All right? One more. Which best represents the volume of a cube? Now, if you were on your own and you're doing homework, you could Google what is volume of a cube. How do you find it? Well, here's a cube. Basically, a cube is like think of a Rubik's Cube, if you remember what those things are. I think those things have come back a little bit. I see students walking around with them. It's three-dimensional. A cube has, to get volume, it's all the space that fills that cube. So you do length times width times height, and you get all the space inside the cube. Or a simpler way would be, since it's a cube, all the sides are the same, so it's the length of a side cubed, which basically means side times side times side. Whatever the length of the side is, you multiply it by itself 3 times. So they're telling us each side is 4x squared. So to get my volume, it's going to be 4x squared times 4x squared times 4x squared. Now, the same rules apply. The big number coefficients, we're going to multiply. 4 times 4 times 4. And that is not 4, 8, 12. This is wrong. 4 times 4 is already 16. And then 16 times 4, what do you get? Let's go ahead and put it in. 4 times 4 times 4. 64. Okay, so we're down to either C or D. Just by getting 4 times 4 times 4. Now these, we do not multiply. We do 2 plus 2 plus 2. 2, 4, 6. 64x to the 6th is that answer.